Hello, ladies and gentlemen. This is BMW Backhaus from BMW. Thanks for joining today's talk about OPCUA at the BMW Group. And I would like to focus on edge computing and OPCUA as a success factor for future manufacturing. Yeah, so as you can imagine, I would really love to talk about cars, but today's talk unfortunately is not about cars. It's about leveraging edge computing and OPCUA for our future production systems. And with having that in mind, first look back in the current situation. As you can see, the mess on the left side, a symbolical picture of our IT production landscape. We have a lot of different hardware for each of the production steps. A lot of suppliers have proprietary standards. The shop floor and its IT systems, of course, they have different stakeholders, for example, for maintenance or quality inspections. And a lot of plants, they create their own solution, and these are not known to the central IT. So our main goals for the future are standardizing the custom solutions and the interfaces to get a better maintainability, and that focuses not only in the IT but also to the shop floor, in that case then using OPCUA. Of course, also data-driven is becoming more important, so the easy data access, for example, for analytics use cases really helpful. But of course, also the global scaling possibilities are big topics, because the overall goal to create a breathable production system, which is possible to scale throughput plus minus 20% at any point, is a big topic we are currently working on. And as said, I want to talk about edge computing and OPCUA. How do these two connect? So at BMW, we have a cloud-first strategy, but of course there are use cases for edge or needs that we need some edge computing. First of all, control loops or latency requirements. Second, of course, where we have some spherical devices that we have to directly connect, for example, a camera. And of course, in a lot of use cases, we have a high data volume where we then want to do some pre-processing to reduce the throughput to the cloud. And of course, data privacy, some kind of data should stay inside the plant or the enterprise barriers. And that works quite well together with OPCUA, because with its standardization, it's a big benefit to the goals we've seen on the first slide. Also, of course, with the information models and companion specifications, for example, for robots, that helps us a lot. Third topic, of course, the interoperability of the components with using OPCUA, and especially using cloud, public cloud, and edge computing. Security is a bigger topic than before. So with the functionalities OPCUA offers, that's a big help for us leveraging these technologies. So looking at our IT target architecture for 2030, and as you can see by the name, that's something we're currently working on. We're not completely there. You can see in the middle that biggest part of our IT landscape will sit in a public cloud. And on the left-hand side, where you see shop floor logistics IT, in that case, that's on Microsoft Azure. In other cases, for example, for our cloud data hub that is sitting on AWS. I want to highlight some major things here in the picture. First of all, the integration layer in the middle part, where we're doing some decoupling of services on the IT, but as well as on the shop floor side. Main technologies there is based on Kafka for streaming service, and API gateway for more the REST-based interface side. And two big topics I want to talk today is, for example, is the edge platform and edge computing, here highlighted in yellow, and OPC-UA is our common standard for equipment connectivity. Of course, we will have some legacy world because we really have long-running equipment, over 20 years or so on the plants. But OPC-UA is definitely the way to go here for the new architecture. Yeah, so focusing first of all on the edge platform and its capabilities. So a little abstract picture of the one we've seen before, focusing on the edge device and streaming service. Edge platform consists of three main parts, which is the provisioning service, device and application management, and the edge store. And all these three enable the business departments and also IT departments to centrally manage and operate and configure apps like OPC connectivity app to deploy them to the shop floor to an edge device. What are the main features in a life cycle of such application? And these applications are also used in a self-service manner by our business departments, like, for example, maintenance. They can find, install, and manage their application. They can also operate and roll out them. Using all these functionalities, and also if they are building up some new application, they also can contribute them to the rest of BMW, share them across plants, across countries, and make them globally available. Main benefits are for us in that case also, we focus here on standardization. So all these applications are packed in Docker containers with central IT policies. As I already told, the contribution from different departments is possible. We're focusing on hybrid approach, so that edge device could be an industrial PC directly sitting at a production line, but it also could be an on-prem data center, so on a higher level. And also with that platform, we are enforcing security functionalities like container checks or device policies. But of course, the most important use case on the edge is machine connectivity. So not only southbound connectors, for where OPC-UA is our main focus, but of course also data transformations, and then to provide them on northbound to other cloud services or the streaming services in our case. And we're focusing on OPC-UA. I would also like to introduce the main phases of what we've done in the past doing right now. First of all, of course, in the first step, you have to establish OPC-UA as a standard for new equipment. So first of all, then of course that started with some tests and so on in our production sites. And so all new equipment is at least OPC-UA ready, has OPC-UA service on board, and can be integrated in the future into new applications. Then during operation and building of cars, OPC-UA works good together with our edge functionalities. With OPC UA as a standard, the central managed rollout and changes in the data access is easy possible. Also from business departments, for example, for failure analysis, the flexible and ad hoc data access is really a key success factor. But of course also for the integration of new IT application, that's a big help with the common interfaces companion specification, which OPC is providing. But of course also if you have to do some replacement or some modification in your production equipment, you can do that across suppliers if they're all sitting on the same companion specification and OPC UA standards, which makes it also really easy to integrate and exchange here. I would like to focus in the next two slides to use cases. Of course, there are a lot of other use cases which are rolled out inside BMW. I would like to highlight two of them. First of all, the dust analysis on the edge in the paint shop that you can see here in the background. In that case, we have the edge device you can see here, which have some connectivity to sensors, but also OPC UA connectivity to PLCs to get some more information about the whole environment, where we are doing then a particle analysis model directly on the edge and just providing the results to higher IT production systems to ensure quality here in our paint shops. The second one is not the classic data use case, so to say. It's in the field of autonomous transport system, and you can see one of these robots. They are traveling around the plant, and of course there are some cases where there are doors. And in that case, we are also using edge devices with an OPC UA connector to the PLCs to control these doors, so open closing doors. And also in that case, our ATS fleet service management also sits in the public cloud. So that's really already in the target architecture an application, and that's also already used in our plants. Yeah, we're not only doing that for our own, we're also doing that in a community. That's why we founded, together with the colleagues from Microsoft, the Open Manufacturing Platform. After that, also a lot of other companies joined us, as you can see here on the logos. Currently, we're working in different working groups, for example, reference architecture, semantic data structuring, or autonomous transport system core services. But also on IoT connectivity. And IoT connectivity focus on, of course, some architecture discussion, the sharing of know-how and best practices. But the main focus is it's about developing code together and provide them as open source. And all that is based also on OPC UA as a common standard there. And if you would like to join, just go to openmanufacturing.org and click there to join us or get some more insights. For example, you can also get our white papers there, and we will happy to get new members there. Yeah, that was my presentation for today. Thank you all for joining. If you have some questions, please get in touch, and have a good day. Bye bye.